Okay. Good morning, my dear students. Welcome to SATYAM TV live classes. I am your science teacher, Miss ROOPA CHOUGALA from CT SOTAISI International Public School, CHIKKODI. And here, this last session we studied about what are the acids, bases, and what are the chemical properties of these acids and bases, and how they react with metals and how they react with each other, acids and bases. And here the next topic is what is the common thing in acid and base. What is the common thing in acids and bases? Here first one, consider acids. All of you already know that acids, they are containing H plus ions. Here these acids, they are having H plus ion common. All acids having H plus ion, it is called hydrogen ion. Okay, all acids, they are having H plus ion, means hydrogen ion as a common. Here, and the next step is, here the H plus ions, they are responsible for the acidic properties of acids. These H plus ions, these are responsible for the acidic properties of acids, their acidic properties. The acidic properties due to the presence of H plus ions in acid. Here consider some examples. First one, HCl. HCl, then it gives H plus, then Cl minus, and next one H2SO4, it gives H plus SO4 minus. And third example, HNO3, sulfuric, here nitric acid, and it gives H plus and NO3 minus. Then fourth one, acetic acid, CH3COOH, it gives H plus plus CH3COO minus. Here these all acids contains H plus ion as a common. When these acids give in aqueous solutions, they give these H plus ions, means they produce H plus ions. That's why the common thing in acids, it is H plus ions. The next step is what is the common in bases. The common thing in bases, you already know that when bases dissolve in water or in aqueous medium, they give OH minus ions. Here bases, all bases have OH minus ion. This is called hydroxyl ion. Here all bases, they have OH minus. OH minus means hydroxyl ion common. Then here also in bases, hydroxyl ion, it is responsible for the basic properties of this bases. OH minus. It is responsible for the basic properties of bases. And here consider some examples. NaOH, sodium hydroxide. It gives Na plus OH minus. Then second one, KOH, potassium hydroxide. It gives K plus and OH minus. Then next example, magnesium hydroxide, MgOH twice, and it gives Mg plus 2OH minus. The same calcium hydroxide, CaOH twice. It gives Ca plus 2OH minus. You consider these all bases having OH minus hydroxyl ion as a common. Then the common thing in bases is OH minus hydroxyl ion. This is about what are the common things in acids and bases. And here in generally we can indicate that acids, they are having H plus, and base, they are having OH minus. This is the common thing. In all acids, the common thing is H plus, and in all bases the common thing is OH minus. This is about what are the common things in acids and bases. And the next topic is acids and bases in water. Acids and bases in water. Here when acids dissolve in water, they produce H plus ions. Here acids and bases in water. First one, acids. When acids dissolve in water, they produce H plus ions. But here these H plus ions, they do not form in the pre or do not form in individually. That's why we are considering H3O plus ion. H3O plus means it is called hydronium ion. Here it does not exist in the free form or individually. That's why we are taking as H3O plus ions. Like here, consider example HCl plus H2O, means when hydrochloric acid it dissolves in water, then it gives here H3O plus. Here one H is there and here H2O, H3O plus Cl minus, and here same, it combines with water, it gives H3O plus and Cl minus ion. Always it is formed in the this form H3O plus hydronium ion, because it does not exist in H plus form. And next one, bases. You already know that bases they gave OH minus ion, and here when sodium hydroxide we combine with or dissolve with water, and they give sodium hydroxide. When they dissolve in water, they give Na plus and OH minus. Here as it is, when they gave directly OH minus and they exit in the form of OH individually, but here in acids they can't exist in the H plus ion, that's why we are taking H3O plus. Same here, KOH, potassium hydroxide, when they dissolve in water, then it gives K plus and OH minus. This is about the acids and bases in water. And the next step is dilution of acids and bases. What is meant by dilution and how the dilution process will takes place? Here the dilution is nothing but the mixing of acids or bases with water. The next step is dilution. Here dilution of acids and base both. Here dilution means it is a mixture of acid or base with water, and it decreases the concentration of H plus ions or OH minus ions, and this process is known as dilution. It decreases H plus or OH minus ion concentration. When we dissolve acid or base with water, and here it decreases the H plus or OH minus ion concentration. H plus means in acids and OH minus means in bases. It decreases their concentration, and this is known as the dilution of acids or bases. And here, while diluting the acids or bases, we have to put acid to the water, not water to the acid, because this process of dilution is highly exothermic. You already know that what is meant by exothermic reaction in the first chapter. Here the exothermic reaction means it is a reaction in which the heat is produced along with the formation of product. Means in the dilution process it produces high amount of heat. It produces high amount of heat. That's why we are considering the dilution process is an highly exothermic process. And here, while diluting the acids or bases, we have to put acid to the water, not water to the acid, because when we add water to acid, it causes some like splash, all the solution splash outside. Otherwise it causes burning. Sometimes in a glass materials they may break. That's why we are adding the acid to water, not a water to acid. Here consider it is an acid and this is water, and in the next step it is water and this is acid. Here we do not add these water to acid. Here this is a wrong method. Here we are adding this acid to water. This is a right way for the preparation of dilution of any solution. It may be acid or it may be base. We can easily prepare the dilutions of these acids and bases. This is about the dilution of acids and bases. And next move towards strength of acids and bases. What is the strength of acids and bases? Here the next step is, what is the strength of acids and bases? Here, strength of acid and base. You can find out these strength of acids and base by using universal indicator. By using universal indicator. Here, by using this universal indicator, we can find out the strength of acids and bases. And here, what is meant by this universal indicator? Here, the universal indicator is nothing but it is a mixture of different types of indicators, and it changes its color for different concentration of ions. Here, this universal indicator, it is a mixture of several indicators, and it changes its color for different concentration of acids and bases. And here we are using pH scale. Here we are using pH scale. pH scale is nothing but it is a scale. It is used for the determination of strength of acid and bases. Here pH scale, it is a scale used to determine the strength of acid and base. Here, that is pH scale. And here pH, in pH, here P stands for, the word meaning, it comes from German. P means potential. Here in pH, P, the meaning of P, it comes from one German word, that is potential. The potential means power. The potential means power, and here pH means the power of H plus ions. Here pH means the power of H plus ions, and same pOH means the power of OH minus ions. By using these pH scale, we can easily find out the strength of acids and bases. And here, how the pH scale, the formation of pH scale takes place. Here, the pH scale, it contains 0 to 14 numbers. It contains 0 to 14 numbers. It is an scale. pH scale. Here it contains the values. Here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and last 14. It contains 0 to 14 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And here the values 0 to 6 we called acidic. The values 0 to 6 we called acidic. And the values 8 to 14 we called basic. And the middle one, exact 7, we called neutral. If the value is exact equal to 7, then we called neutral. And the value, it may be 1, 2, 3 or something, 0 to 6, we called acidic. And 8 to 14, we called basic. This is about the pH scale, how the numbers are arranged on the pH scale, and by using these numbers, how we can find out the strength of acids and bases. And here the pH is equal to 7, we called this is neutral solution. Okay, the pH is equal to 7, then we call neutral solution. If pH is less than 7, pH is less than 7 means here 0 to 6, then we called acidic solution. And next, third one, pH is greater than 7 means here it is 8 to 14, then we called basic solution. Okay, this is about the pH scale. pH scale, it contains the values 0 to 14, and here 0 to 6 values we call acidic, and 8 to 14 we called basic, and middle one 7 we called neutral. And here the pH is equal to 7 means we called that solution is neutral solution, and the pH is less than 7 means 0 to 6, we called acidic solution, and the pH level is greater than 7 means here 8 to 14, we call it is basic solution. And next one, what is the importance of these pH in our daily life? And you already know that our stomach, it releases hydrochloric acid, HCl, and that HCl is very helpful for the digestion of food. Here the importance of pH in daily life. Here our body works pH under 7 to 7.8, 7 to 7.8. Our body works the pH under 7 to 7.8, and our stomach, it releases HCl acid, hydrochloric acid, and this HCl acid, is very helpful for the digestion of food. Sometimes indigestion takes place in our stomach. At that time, this HCl, release of this HCl is high, and it releases more HCl, then it is called acidity. You already know that what is meant by acidity. It is stomach burning and pain takes place when we are suffering from acidity. When the HCl is releases more. If it is medium, then it is good for the digestion of food. And next one, here our tooth decay will take place when our mouth pH is less than 5.6. Our mouth pH is less than 5.6, and tooth decay will take place. And the pH of our blood, pH of blood is, it is 7.3 to 7.4, 7.45. The pH level of our blood is 7.35 to 7.45. And here the pH of soil. Here pH of soil. Here all plants, they require different types of pH for their healthy growth. Here consider example rice. This rice, it wants acidic pH. Rice plant, it requires acidic pH. And sugarcane, it requires neutral pH. Means different types of plants, they need different types of pH levels for their healthy growth. Okay, this is about the importance of pH in our daily life. The next one, what are the common acids and their sources? The acid and their natural sources. Here what the names of acids and their natural sources. First one, acetic acid. Here the first one, acetic acid. Here the natural source is vinegar. This acetic acid we are getting from this vinegar. And the second one, citric acid. Citric acid, it comes from lemon and orange. And the third one is tartaric acid. Here the third one acid is tartaric acid, and the natural source is tamarind. And the fourth one, lactic acid. Here the fourth one is lactic acid, and its natural source is curd. We are getting this lactic acid from curd. And fifth one, oxalic acid. Oxalic acid from tomato. This oxalic acid, the natural source is tomato. And the sixth one is methanoic acid. Methanoic acid. And the natural sources are ant sting or nettle sting. After biting the ant and nettle, the methanoic acid is formed. Here these are the some natural acids and their sources: acetic acid, citric acid, tartaric acid, lactic acid, oxalic acid and methanoic acid. These are some examples for natural acids and their natural sources. And here the next topic is more about salt. In last session we studied about what are the salts and their properties, and here we are studied about more about these salts and which compounds are formed by these salts. And you already know that these salts are formed when acids and base combine with each other and they form salts. And next one, family of salts. family of salts. Here the combination of acid and base, it gives acid plus base, then it gives salt. And next one, family of salts means, here consider example KCl and NaCl. Here potassium chloride, it is also an salt, and sodium chloride is also an salt. And here what is the common thing? It is Cl. And the family is this, these two salts are belong to chloride family. Okay, because they are having Cl common, means chlorine. These KCl and NaCl, these are belongs to chloride family. And next one, here NaCl and Na2SO4. Here sodium sulfate and sodium chloride. Here what are the common things? Na and Na. And these two salts are belongs to sodium family. Means what is the common things are in these? NaCl and Na2SO4. Here the same magnesium family is there, and calcium family. Means the salts, they are having common things, Mg and Ca, calcium. And here these are the chloride family, belongs to chloride family, and these are belongs to sodium family. And here the next step is the pH of salts. What are the pH of these salts? How we find out the pH of these salts? pH of salts. Here first one, the combination of strong acid and strong base. Strong acid plus strong base. Here the combination of strong acid and strong base, it is neutral salt. Means the pH is equal to 7. When the combination of strong acid and strong base, it gives neutral salt, and the pH is equal to 7. And second one, the combination of salt of strong acid plus weak base. Here the combination of salt of strong acid and weak base, it gives acidic salt, and the pH is less than 7. And next third one, the combination of salt of strong base. The combination of strong base plus weak acid. The combination of strong base and weak acid, it gives basic salt, and the pH is greater than 7. This is about the pH of salts. Here when the combination of strong acid plus strong base, then they gives neutral salt. The neutral salt pH is equal to 7. And the combination of salt of strong acid and weak base, they gives acidic salt and their pH is less than 7. And next, the salt of strong base, vice versa, opposite, and weak acid, they gives basic salt and the pH is greater than 7. And here the next topic is the chemicals from common salts. What are the chemicals found by these normal or common salt? And here chemicals from common salt. Here NaCl. NaCl is called common salt, or sometimes we call table salt. NaCl is a common salt, otherwise it is called a table salt. And how the NaCl is formed? The combination of sodium hydroxide plus HCl. When the combination of sodium hydroxide and HCl, it gives NaCl plus H2O. Okay, the formation of NaCl. In the combination of NaOH plus HCl, it gives NaCl, sodium chloride plus water. And here this NaCl is neutral salt. This NaCl is neutral salt. If it is neutral means what is the pH of this NaCl? If it is neutral means the pH of NaCl is equal to 7. The pH is equal to 7. And by using this common salt, we can prepare so many chemicals. For example, NaOH, sodium hydroxide, and bleaching powder. And the third one is baking soda. Then fourth one, washing soda. These are the chemicals prepared with the help of this common salt, that is NaCl. And here, what are the uses of this NaCl? Uses. Commonly we are using this NaCl, common salt or table salt. We use enhance the taste of food. It increase the taste of food. And already know that with the help of this NaCl we can prepare these all other chemicals, NaOH and bleaching powder, baking soda and washing soda. Here let's discuss about one by one how these chemicals are prepared with the help of sodium chloride. And that first one is sodium hydroxide. Here some chemical methods are there. By using these chemical method we can prepare these remaining chemicals with the help of sodium chloride. Here first one, the preparation of NaOH, sodium hydroxide. First one, NaOH, name is sodium hydroxide. Here, when the electricity is passed in the solution of aqueous solution of NaCl, then it gives NaOH. Here, when the electricity is passed through NaCl, then it decomposes to NaOH. Here, when the electricity is passed through the aqueous solution of sodium chloride, it decomposes into NaOH plus Cl2 plus H2. Here, when this sodium chloride, it decomposes and it gives sodium hydroxide and Cl2 and H2. Okay, and this is the formation of sodium hydroxide with the help of NaCl. And next one, what are the uses of this sodium hydroxide? Sodium hydroxide is used for the manufacturing of paper industry and the manufacturing of glass industries. And next one, these NaOH crystals, they are using for the preparation of bleaching powder. For the preparation of bleaching powder. These are the uses of sodium hydroxide. And the next second chemical is bleaching powder. And the second chemical is bleaching powder. The chemical formula of this bleaching powder is CaOCl2. CaOCl2. Then when this chlorine reacts with calcium hydroxide and it forms bleaching powder. Here Cl2 and CaOH twice. When this chlorine, it reacts with calcium hydroxide and it gives CaOCl2. This is bleaching powder plus it gives water. When the Cl2, it reacts with calcium hydroxide and it gives CaOCl2, bleaching powder plus water. And next one, what are the uses of bleaching powder? Here the bleaching powder is used for cleaning property. It is having cleaning property, that's why we are using as a cleaning material. It is used to kill weeds. It kills weeds. And next one, it is used for as moss remover. It is used for the removing of moss. And next one, it is used in the, like paper industries and cloth industries and all. This is about the uses of bleaching powder. And the next chemical is baking soda. And the next chemical is third one, baking soda. And the chemical formula of this baking soda is NaHCO3. This is a chemical formula, and the chemical name is of this NaHCO3 sodium bicarbonate, otherwise sodium hydrogen carbonate. Sodium bicarbonate, or in another word, sodium hydrogen carbonate. These two are the chemical name of this baking soda. And here, when the combination of NaCl plus CO2 plus NH3 plus water, here the mixture of sodium chloride, carbon dioxide, ammonia and water, then it gives NH4Cl. This is ammonium chloride plus NaHCO3. This is sodium bicarbonate or sodium hydrogen carbonate. This is about the formation of baking soda with the help of sodium chloride. And next one, what are the uses of this baking soda? Here the baking soda we are using as an antacid. It is used as an antacid when we are suffering from acidity. Then its baking soda is act as an antacid and it removes the causes of that acidity. And next one, it is used as for the preparation of baking powder in bakeries. Baking soda is used for the preparation of baking powder in bakeries. And next one, it is used in fire extinguish. It is baking soda is used in fire extinguish. These are the uses of baking soda. And the fourth chemical is washing soda. And the fourth chemical is washing soda. And the chemical formula of washing soda is Na2CO3. That is sodium carbonate. The name of this compound is sodium carbonate. Here, when Na2CO3 sodium carbonate, it combines with 10 moles of water molecules, then it gives Na2CO3 10H2O. Here Na2CO3 10H2O means the sodium carbonate, it contains 10 water molecule in its compound. And next one, uses. What are the uses of this washing soda? It is also used as a cleaning material, means for the preparation of detergents. it is used for the preparation of detergents and for the preparation of soaps, and it is used for manufacture of borax, like borons and all. For the manufacture of borax we are using washing soda. And next one, here detergent powder and detergent cakes like soaps. By using this washing soda we can prepare these materials. And the last thing is POP. What is mean by POP? That is plaster of Paris. The next chemical is POP. Name itself indicates plaster of Paris. POP. And the formula is this is the chemical formula of POP. Calcium sulfate and half H2O. Half H2O means hemihydrate. Here calcium sulfate hemihydrate. If it is 1 H2O means monohydrate, 2 means dihydrate, 3 means tri, same, 5 means penta. Like here half H2O is there, that's why we are calling calcium sulfate hemihydrate. Here how the POP is formed. When on heating gypsum, it loses its water molecule and it becomes POP. On heating gypsum. Here the formula of gypsum is CaSO4 2H2. The formula of gypsum is CaSO4 2H2O. On heating this gypsum, it becomes CaSO4 2H2O. Then on heating it gives CaSO4 half H2O. This is POP. Then again we add water to this POP. Then it again becomes calcium sulfate dihydrate, means it contains 2 water molecules. And this is about how the POP is formed with the help of gypsum. And here the next topic is the water of crystallization. And here the next topic is the water of crystallization. Water of crystallization. Here water of crystallization means it is nothing but the how many water molecules are present in that crystal or compound. So the next topic is water of crystallization. Here water of crystallization is nothing but the number of water molecule present in that compound. Number of water molecules present in the compound. This is known as water of crystallization. Here consider an example. CuSO4 5H2O. Here this is copper sulfate pentahydrate. Pentahydrate means here it contains 5 water molecules. Means it contains 5 water molecules. That's why we are calling pentahydrate. And this copper sulfate is in blue color because of the presence of water molecules. When we heat this copper sulfate 5H2O, copper sulfate pentahydrate, then it lost its water molecules, then it becomes CuSO4, only copper sulfate. This is blue color, and after heating it becomes gray or white color. Okay, this copper sulfate is blue in color because of the presence of 5 water molecules. After heating this copper sulfate, it becomes copper sulfate only. It does not contain any water molecules, and the color changes from blue to gray. And here some examples are there. Like if it contains 7 water molecules means it is called heptahydrate. Like here FeSO4 ferrous sulfate plus 7H2O. It contains 7 water molecules. Here 7, and 8 means octa and 9 means nona, like this. How many water molecules are present in that compound or crystal? We known as the water of crystallization. Okay student, this is about the water of crystallization, and this is the end of this chapter, and this is also the end of this session. And in the next session we will start a next new chapter from the 10th standard science class.
ವೀಕ್ಷಕರೇ, ನಮ್ಮ ಸತ್ಯಂ ವಾಹಿನಿಯ ಪ್ರತಿದಿನದ ಅಪ್ಡೇಟ್ ಮಾಹಿತಿಯನ್ನ ತಿಳಿದುಕೊಳ್ಳಲು ಸತ್ಯಂ ಟಿವಿ ಕನ್ನಡ ಯೂಟ್ಯೂಬ್ ಚಾನೆಲ್ಗೆ ಸಬ್ಸ್ಕ್ರೈಬ್ ಆಗಿ ಹಾಗೂ ಬೆಲ್ ಐಕಾನ್ ಅನ್ನು ಕ್ಲಿಕ್ ಮಾಡಿ.